Waves have many different types of motion. For example, we have a molecule that might be vibrating up and down or oscillating up and down, and that's the displacement of the material or the molecule of this water wave. It might be a piece of string on a string that you're sending a pulse down, or a surface water molecule at the surface of a water wave, and it moves up and down. And that happens for all the molecules along the wave. So here's another molecule that's moving up and down, and even one right here that at this moment in time is at equilibrium. It's going to be oscillating up and down. And the way that we know how these oscillate up and down is because the wave itself is traveling. So this is the wave speed, whereas these are that's the motion of the molecules displacing the displacement from some equilibrium point. So the question is, how do we quantify this? How do we describe this in detail? And it works best if we try and break apart some of the time information from some of the spatial information. So the spatial information is, where are all of the molecules at one moment in time? That's called a snapshot graph. So if I take a picture, I'm going to draw a coordinate system here, and I have a wave that at one point in time looks like that. Then my axis would be position. I'm seeing the entire wave. This might be a string. I'm seeing the entire string, but at one point in time. And so this would be the displacement of that string as I look at the entire string. This is a snapshot graph. It's like taking a picture. That's what we call snapshot. Snapshot graph. Okay, so we get all the information at some specific time. So t equals t1. There has to be one moment in time to see that. And that gives a lot of information. I can see where it's at. I can see that this molecule this time is up here. I can see at this moment in time, I can see that the molecule at the origin is not at the origin, it's somewhere else. And a question then is, well, what's the shape of this going to be at a later time? Okay. Well, I need some additional information. I could say that the wave is moving to the right, and if that's true, then I could tell you that this piece of string right here that currently is at the origin, or it's at the equilibrium plane, it's going to move up, because as this piece right here moves this way, or as the disturbance moves this way, it's going to pick this piece of string up. And so this piece of string is going to go upwards. And so at a later time, I'm going to have this part right here, and I can do that sequentially through everything. Okay, this part's going to be a little bit higher. It's going to be over here. This part is going to be a little bit lower because this piece is moving in. Okay, so that what was right there, this piece is going to come down as this disturbance moves that way. And so what I end up having is I could connect these dots, and that is where it's going to be at a later time. So this would be T2 greater than T1. Okay? And so I can keep doing that and try and get all the information. But these two different curves would be snapshots. This is at one time, and this is at a later time. And knowing the motion of the wave, the velocity of the wave, or speed left or right, I can then infer what is going to happen at a later time. So that is a snapshot graph. Now a history graph is a little bit different. A history graph is a function of time. Okay? We still plot the displacement, but now we're looking at not a single point in time, but a single point on the string or on the wave. So we have x equals some position, some specific position. So maybe let's talk about this position right here. Let's call that x1. Okay, for this wave. So we have x equals x1, and we know that this wave is moving to the right. And so well, let's go ahead and say t1 equals 0, just to make it simple. Okay, so if this is t equals 0, here's 0 right here, okay, where is that spot, that piece of the material at t equals 0? Okay, well, it's got a 0 displacement, so I draw a dot right there. Okay, where will it be later on as we get for t2 greater than 0? Well, we can see that as this wave moves through, it's going that way, this is going to get pulled down, and so it's going to come down. And so I'd have it come down a bit. A little bit later, this piece will get over to there, which means it'll come down all the way to here, and so it'll get down further, and this piece will get over there, and then this piece will get over there, and so on and so forth. And I can see I get something like that with time. And so that spot is moving up and down, but we can see, we can generate that curve as a function of time by considering what's happening as this wave moves through. This now is called a history graph. Okay. The history graph tells me what's happening at a certain point as time ticks on. Okay. Now, to understand the entire motion, I could either have a video and be able to describe it that way, but on paper or in equation form, I need to have two different bits of information. I can either have a snapshot graph and know the velocity, the speed and the direction. Or I could have a snapshot graph and the history graph, and from that I can imply the direction of the wave moving. Or I can have the history graph and then and then knowledge of the wave. Now I couldn't draw it here because this is not moving, this is not space, so I'd have to say something like v equals v wave, okay, with its plus or minus. I'd have to know that in addition to the history graph to then be able to create a snapshot graph. And we'll do some examples. But the main thing to recognize is how are they different? Snapshot graph describes the entire graph at one moment in time, or the entire material at one moment in time. The history graph describes one point in space for a time period, for multiple times. And in order to have enough information to describe all of the wave, we need to have two pieces of information from these three. Either the wave speed and the snapshot graph, the wave speed and the history graph, or the snapshot graph and the history graph. And then we can infer the other from those.